For this week, we're going to see how to apply Q is equal to mc delta T and how to apply delta H is equal to minus Q over N. So we'll see these two equations. So heat changes, like we said previously, heat is Q. Heat changes can be calculated from temperature changes. Temperature changes would be delta H, which is final temperature minus initial temperature. So from temperature changes, you can get heat using this equation, where Q is heat change in joules. Unit is very important here. So Q is in joules, mass is in grams, C is the specific heat capacity of the substance in joule per gram per Kelvin, and delta T is temperature change, that is final temperature minus initial temperature, and this will be in Kelvin. Now, normally, even if temperature is given in degrees Celsius, let's say initial temperature is 10 degrees Celsius and final temperature is 20 degrees Celsius. The change in temperature here is 10 degrees Celsius. The change in temperature is also equal to 10 Kelvin, because if you convert 10 degrees Celsius into Kelvin, this will give you 283 Kelvin. This is the initial temperature. Final temperature, this will give you 293 Kelvin. Remember, degrees Celsius to Kelvin, you add 273. Now, the difference between these two is 10 Kelvin. So, change in temperature, whether it is in degrees Celsius or whether it is in Kelvin, the change in temperature will be the same, whether it's in degrees Celsius or Kelvin. Now, the specific heat capacity of a substance, generally you'll be using that of water, which is given in section 2 of the data booklet. Here, specific heat capacity of water, CW, is 4.18 kilojoule per kilogram per Kelvin, joule per gram per Kelvin. Now, these two values are the same. The only difference is in the units. You just have to be very careful. If you use CW in this unit, if you use it in kilojoules per kilogram per Kelvin, your Q is going to be given in kilojoules. It's here. Your M will be used in kilograms. It's here. And your temperature will be in, your temperature change will be in Kelvin. If you're using this unit here, then the Q will be in joules and the mass will be in gram. You just have to be very careful with the units. For now, it doesn't seem to make a lot of difference because the values of C is the same. But when you look at the question, the units of Q and the units of M will make a difference. So you have to be very careful. Now, C is specific heat capacity. Specific heat capacity indicates the amount of heat that is required to increase the temperature of a substance of 1 kilogram or 1 gram by 1 Kelvin. So it depends about the unit of mass. If we are using specific heat capacity in joule per gram per Kelvin, then it's the amount of heat required to increase the temperature of 1 gram of substance by 1 Kelvin. If you're looking at unit of specific heat capacity in joule per kilogram per Kelvin, then it is the amount of heat required to raise the temperature of 1 kilogram of substance by 1 Kelvin. So you have to be just careful about the units. The lower the specific heat capacity, the higher the rise in temperature for the same amount of heat transferred to the system. If I rearrange the equation, I'm going to have, so the lower the specific heat capacity, the higher the rise in temperature. So delta T is going to be higher. The higher the specific heat capacity, the lower delta T is going to be, because specific heat capacity has an inverse relationship with delta T. So this is what it means. So if you look at these three substances, water, ethanol, and copper, water has the highest specific heat capacity, and copper has the lowest specific heat capacity. And if you think well, copper is a very good conductor of heat. So a small amount of heat results in a high change in temperature. Now, using the information from the table above, try to find which of these statements is correct. Pause the video, think about it, and then you can check your answer. So if you look at option A, it's talking about heat to raise the temperature of a fixed mass by a fixed temperature. So mass 50 gram is the same temperature, 50 degrees Celsius is the same. So which means that if I use this equation, mass and temperature is the same. So we're looking at the relationship between Q and C. So Q is directly proportional to C. So if specific heat capacity is higher, heat required is going to be higher. So if you look at heat capacity of water, it's higher than specific heat capacity of ethanol. So then the energy required to increase the temperature of water is going to be higher. So heat required to increase temperature of water is higher than that of ethanol. So this is a correct statement. Now, if you have equal masses of two substances, X and Y, absorbing the same energy, the temperature rise by 5 degrees Celsius and 10 degrees Celsius. And you need to find which of them is correct. So for this kind of question, I'm going to start by writing my equation. Q is equal to mc delta T. It says equal masses. So if masses are the same, I'm not going to consider it. Same amount of energy, Q, I'm not going to consider it. So from this, you can find that Cx delta Tx will be equal to Cy delta Ty. So I'm just equating here for two substances where Q and M is the same. C multiplied by T will be the same value. So delta Tx is 5 and delta Ty is 10. So then Cx over Cy is equal to 10 over 5, which is equal to 2. Therefore, Cx is equal to 2 times Cy. So specific heat capacity of X is twice that of Y. So this is what it means. So statement A is correct. Question 3. How much heat is released when 10 grams of copper of a specific heat capacity here is cooled from this to this? So we are just asked to find Q. So Q is equal to mc delta T. So when I said pay attention to the unit, this is what I mean. So you see, this is in joule per gram per Kelvin, which means that my Q will be in joules and my mass will be in grams. So here this is 10 grams, so I can use 10 grams. I can use the value of C as given, and the change in temperature, this is going to be 85 minus 25. So this is my value of Q, and this is in joules. Find enthalpy change from heat. Enthalpy change is delta H, heat is Q. So delta H is minus Q over N, where N is number of moles of limiting reagent. Now, if you think well, Q is heat. Now, you can have reaction where heat is liberated or a reaction where heat is absorbed. If heat is liberated, delta H is negative because it is exothermic. And when heat is absorbed, delta H is positive because it is endothermic. Now, when it is exothermic, final temperature is going to be greater than initial temperature, so that when you do the difference, it's going to be a positive value. So Q, you know that Q is equal to mc delta T. So this is going to be positive for an exothermic reaction, because change in temperature is going to be positive because final temperature is greater than initial temperature. But for an endothermic reaction, final temperature is less than initial temperature because the substance will cool down. So energy is absorbed. So temperature will decrease. So final minus initial will be negative, will give you a negative value. So Q is equal to mc delta T will give you a negative value. Right? Now delta H is negative Q over N. So when Q is negative, delta H is going to be positive. When Q is positive, delta H is going to be negative. So this is important for you to notice here. So I'm going to do this example, this word example, paying attention to the units here. So it says that you have 1.15 grams of sample of lithium chloride, which is added to 25 grams of water. Temperature rise is given here. And you need to find the enthalpy change. Enthalpy change is delta H for dissolution. Dissolution means the delta H when you dissolve it. Dissolution is just dissolving. And you are assuming that heat capacity of lithium chloride itself is negligible. So the only thing that is involved other than lithium chloride is water. So because you're mixing it with water, you will look at the specific heat capacity of water, which is given in the data booklet. So from the data booklet, you can see specific heat capacity of water is this. Now, which unit to use? It will depend on what I have. So I have the mass in grams here. So I will use this one, joule per gram per Kelvin. So if I use this, I will get Q in joules. So Q is equal to mc delta T. Mass is 25 grams. C 4.18, and delta T is here 3.8. So I get my Q. So I get my Q in joules here. Now I need to find enthalpy, delta H. Now delta H is going to be minus Q divided by N. N is what? N is number of moles. How do I find number of moles? Number of moles is mass over mR. Now, what substance is involved here? It's lithium chloride. So then I can find mR of lithium chloride. I use the data booklet. So I find the mR of lithium chloride. And then I can find number of moles of lithium chloride. Number of moles is mass of lithium chloride that I used, 1.15 grams, divided by a mole. Then delta H will be minus Q over N. Now, you have to know that enthalpy change, delta H, is usually calculated in kilojoules. So this should be in kilojoules. Therefore, what I'm going to do, I'm going to calculate it in joules and then convert to kilojoules. So it's going to be minus 397.1 divided by number of moles, which I just found. And this is going to give me this value in joules. Now I'm going to just convert it in kilojoules, divide by 1,000. So I give my answer in 3SF, 14.7 kilojoule per mole. Because this is delta H is given in kilojoule per mole. That's the typical unit. Right? And it is negative, showing that this is an exothermic reaction. Using the same principle, you will do worked example 2, question 1 and question 2. The only thing in question 2, the unit here has been misprinted. This is joule per kilogram per Kelvin. So just pay attention. This unit is wrong here. It should be here. So you will now do these 3 questions. That will be your homework for this week.